Okay, by looking at this table, you can see that regular, well, or in general, geometries, but most of them regular such as square, triangle, circle, semicircle, those are regular geometries, and those areas and centroids are provided in this table. So make sure you have access to the table, or you can even remember some of them, like the area of circle is pretty easy. It's pi r squared divided. Sorry, the area is pi r squared. The area of a triangle is, this is the area of a full circle. So a circle has area of pi radius squared. The area of a triangle is 1/2 its base times the height, and so on and so forth. We already computed the area of a parabola is a, so the area is the base times the height divided by 3. And notice that the height is a number, even though the function that inscribes the parabola can change. Basically, the constant k depends on a and b, as we just saw. So this table will provide a lot of useful information for getting the centroid and the first moment of area for the um, elements that we're gonna study. So let's look at this example. They're asking us to find the centroid and the first moment of area of this geometry. So the first thing we want to do is divide the geometry in regular elements. And the regular elements are a triangular shape, a rectangular shape, and a semicircle. All right, and once we add these three elements, we have to subtract a full circle with diameter 40 millimeters. So to solve for the centroid and the first moment of area in x and y, we have to add the triangular shape plus the rectangular shape plus the circular shape minus, sorry, is the semicircular shape minus a full circle. That will give us what we need. The second thing that we need to decide is where to put our coordinate system. If we place it here, which is what they're doing for us, so we're gonna have to stick with that just for this problem. If we place it here, this length in y is a negative length. Even though the area is positive, we have to consider this area as a negative, sorry, this length as negative because origin is right here. So for instance, this would be positive 120 millimeters, and this length is negative 60 millimeters. On the other hand, if we decided to place the origin, or if they ask us to place the origin here, then everything will be positive, but now this center right here for the circle won't be at 80 millimeters anymore. It will be at 80 plus 60, which is 140, and it will be positive 140. Okay, all right, so just keep that in mind and double check that your coordinate system is somewhere that you recognize. If not, you might be able to change the coordinate system to a place that is more convenient for you, and the result is going to be the same. Meaning that no matter if it's right there or if the coordinate system is here, the point will be the same. The central will be the same for the object. It's just the computations will be different. So let's see that with an example. In order to compute the centroid, we have to find a few things first. So let's create a table. So let's say element, and in the element we have a triangular shape, we have a rectangular shape, we have a semicircle, and we have to subtract a circle. Okay, this distance is -60. This distance is 120. This distance is 80. And this distance is 120. This radius, or this diameter better, is 120. And this diameter is let's say radius for both of them. So this is 40, and up here this is the radius. Okay, the radius is 60. Okay, so that's our first table, or first row, column actually. This is the first column. Then we're gonna have area, or actually it's way simple. Let's start with the centroid, or the middle point of each element in X. The center of each element in Y. All right. The center in X times, well, actually before we do that, we have to find the area in millimeters squared. Then we have to find X times A. Then we have to find Y times area. And actually that's all. So let's get more space right here. Y A. Okay. And then down here we have summation of XA and summation of YA. Okay. And then yeah, that will give us the first momentum in X and the first momentum in Y. So the first momentum in X corresponds to the centroid in Y. Why? So remember, when you have a function Y, so like the function Y is with respect to X. So if you were to plot this, you have your X coordinates and your Y of X. Okay, so Y of X in the vertical axis, X in the horizontal axis. This Y of X is the same thing right here. So this is x of y, this is y of x, meaning that the variable here is y, hence this guy, and the variable for momentum, first momentum of area in y is with respect to x. Okay, so we'll see that in a minute when we're done. We'll review the concept. But just for now, remember that first momentum of area with respect to x is not the centroid in x, is the centroid in y. This has units of cubic millimeters. All right, so we should be able to start. So let's do the first one. The centroid of this triangular shape in x is 60 over 2. Sorry, 120 over 2, which is 60. The centroid with respect to y is 1/3 of 60 times 120. That is equal to 2400. Okay. The area, wait a second, what are we doing wrong? Is 60 times 100 divided by 3. 60, base is 60, height is 120. So we're doing a triangular shape. I did something wrong here. I apologize. I did it wrong. Okay, so let's do this part first. So in x is 120 divided by 1/3, which this is 60. Sorry, 40. I keep saying 60. 120 divided by 3 is 40. All right, and this is x triangle. Y is negative in the triangular shape. It's negative 60 divided by 3. So it's negative 20. Then the area, well, the area should be okay. What did we get here? Was it is 1/2 times 60 times 120, 3600. Okay, so this is 3600. All right, 3600 times 40 is 144,000, and times negative 20 is negative 72,000. Okay, we got the first one. Now let's do the rectangular shape. It's 120 divided by 2, 60. Is 80 divided by 2, 40. Area is 60 times 40, which is 9600. Multiply 60 times 9600 is 60 times 9600 is 570 6,000, so 576, and then it's positive. Now this one is in the positive direction. Is 9,600 times 40, which is 384. 1, 2, 3. All right, the third one. So the third one is the semicircle. So let's do that one. So x is, well, let's do first the area, which is the simplest one. Area of the semicircle is the area of a circle divided by 2. So that is the area of this circle is based on the radius of 60. So this is going to be pi times 60 squared divided by 2, 5654. Let's just say 5655. So 5655. And these units are in cubic millimeters. Okay, now x for the semicircle, we go to the table here and we check that the semicircle area is right here, but in the x direction is at the origin, right? That makes sense. And then the y direction is 4 times the radius divided by 3 pi. Okay, so let's do that. So the origin of this circle is at 60, right? Because it's 120 divided by 2. That's where this origin is. And the origin of in y is 80, because it's placed at this with respect to the origin. So 80 plus 4 times the radius divided by 3 pi, which is equal to 80 plus 4 times 60 divided by 3 pi. Okay, this is 80 plus, this is 120, 3 divided by 80 pi. 3 divided by 6 divided by 3 is 20. Let's just put the whole thing in there. So we can put a decimal. If you want to simplify further, you just know that this is 1, and this is 20, and 4 times 20 is 80. But let's put the whole number down. So let's do 80 plus, and the y direction for the centroid of that element is 4 times the radius, and the radius is 60, divided, parentheses, 3 times pi. Okay, that's 105.46, and it's positive. 105.5. Okay, then we have the area. Then we just need to multiply. We just need to multiply 5655 times 60. So 5655 times 60, which is 339,300. So 339,300. All right, now let's do that number times 105.5. 105.5. We get 596,602. 596,602.5. All right, and then we do this circle. So we have to subtract this whole circle. All right, So let's do, first of all, the area of the circle is equal to pi r squared equals to pi 40 squared equals to pi times 40 times 40, which is 40 squared is 5026. All right, 26.5. Okay, so 526.5. So the area is always positive, but I'm going to place minus so that I remember that I have to, that all of this row is going to be subtracted. Well, the coordinates will still be positive because it's just an element. So it's going to be the same concept. X is just where the origin of the element is at, and it's 120 divided by 2. And y is located at 80 plus 0, it's just at 80. So x times area is equal to, so that number times x, which is times 60, is 301,592. And this is minus, we're going to subtract that. And in y is that number times 80. So it's 402,123. All right. So we got the values to find the total, or to find the actual centroid of the element of the body. What we have to do is do this computation. So -3, let's start one by one. 144,000 plus 576,000 plus 339,300. All right, and then subtract 301,592. All right, I hope I typed everything correctly, and this one is 757. So 7,057. Oh, sorry, 757, 708. So let's type that, 757, 708. 757, 708. Okay, now careful because this one has a negative here, and that is what I was mentioning before. It's just because the coordinate system is here, so this y direction is negative. Had they placed their origin here, this would be positive, but then this centroid would be at 80 plus 60 plus 4r divided by 3 pi. This guy would not be at 80, would be at 80 plus 60, and everything else will be shifted. So this centroid here would not be at 40, will be at 60 plus 40, etc. So be careful there. All right, so negative 72,000. Okay, plus 384,000. 1, 2, 3. Plus 596,602.5 minus, because this is the area that we subtract, 402,123. And this is 506, 479, 480. 506, 479. 506, 479. All right, so in that case, q of x, now remember, my function x is in terms of y, my function y is in terms of x. So q of x is as a function of y is 506, 479, and 757, 708. All right, so we found our first moment of area. Now, to find where that moment is, we have to find the actual x and y of the whole system. And we can do that very easily. So with those numbers, we divide by the area. Okay, so the centroid in x is equal to summation of xa divided by summation of areas. So the summation of that number is equal to 757, 708, 757, 708 cubic millimeters. And the summation of the areas is, we didn't do it, so we need to do it now. Summation of areas. All right, it's 3,600. Okay, 3,600 plus 9,600. 2 plus 5,655 minus 5,026.5. 5,026.5. And that is 13,828. All right, so 13,828.5. So 757, 708 757, 708, yeah, divided by this number equals 54.79. Millimeter squared, millimeter cubic millimeter, millimeters. Okay, so in x, our distance is at 57.8. That's interesting because just this part right here, the rectangular shape plus the semicircle would be at 60. So by adding this triangular shape, it shifted the centroid to the left just by 2.2 millimeters, right? Shifted from 60 to 57.8. All right, that would have been, I would have thought it was much more, but that's interesting. So the next one is pretty easy as well. We have everything, we just need to go to the calculator. So the centroid, the summation of the centroids of all the elements divided by this summation of the areas. And this is equal to 506,479 and 13,828.5. So 506,479, 506,479 is 36.62. 36.62 millimeters. All right, that means that this point right here is at a distance of 36.62 millimeters. All right, that's pretty nice. With this point, when we have a system of forces, we know that we can apply the force in that from that point. So if they tell us the mass, we can compute the weight, and we can know the momentum, say at this point or at some other point, because we know the distance to this point, it would be 36 plus 60, and in x is 57. All right, so to confirm, let's go ahead and see how they solve it. Yeah, so they do the same thing. They create their elements, rectangular shape, the triangular shape, the semicircle, and the circle. They create the table where they compute the summation of areas, summation of centroids, and q of x corresponds to centroid in y, q of first moment in y corresponds to centroid in x. 54, 36. Okay, very good. So this is how you compute the centroid or the first moment of area for rigid bodies.